Hello. What I'm going to try to demonstrate today is Kubernetes' ability to schedule pods to compute nodes based on a labeling scheme. The idea behind this demonstration is that this capability could be leveraged by systems such as ONAP to deploy container-based VNFs to compute nodes that have required hardware capabilities, such as access to the raw network information, raw network device drivers, that type of thing. Idea matching a VNF that requires certain hardware accelerators to hardware that has that accelerator or capability. What I've got here is a pretty basic 3-node Kubernetes cluster. It is running on VMs on my Mac. It has 1 master and 2 workers. The master, I've removed the taint so that the master is allowed to have pods running on it. Other things that we can look at is if I look at the namespaces, just the basic namespaces. I will be adding an ONAP namespace as well as a VNF namespace throughout the demo. Additionally, if we look at the labels on the nodes, and I have just a little demo script that helps me here. I'll actually cat it first. Essentially, it takes the output of get nodes, pipes it through JQ, so that I can get an output that's a little more focused on the things I care about. So when I actually run this, what you see is it just gives me the name of each node and the labels on each node. So you can see, starting off in this cluster, I have just the standard labels on those. So I'm going to create 2 namespaces to begin with. I've just got files to do this. I'll describe these other things as I go through. Oops, to prep the dash F, as I always do in the second one. And now we have namespaces. So if I get namespaces, you can now see I have an active ONAP namespace and an active VNF namespace. The next thing I'm going to do is I'm going to deploy what I've called the detective container. This is just really a sample container hack, very, very bluntly, to represent what a hardware interrogator might look like, and i.e., they could run this container on a compute node in Kubernetes. It would have proper privileges and access to the host machine, and it could then interrogate that host machine to understand which accelerators it has on it. This is just one way to understand what hardware capabilities are. You could also pre-provision them, but for now, let's use the detective. If you look at the detective files, just simple Python, it has 2 basic capabilities. One, periodically, it will go off and query a set of definitions from the web, and then it will use those definitions to interrogate the local hardware and add labels to the local compute node. In practical terms, that's kind of in the abstract how we could build a detector. In practical terms, it does pull a definitions file from the web. I just said I've hosted up in Gist, and it will then use kubectl commands to add labels to the host on which it's on. The file for I will start these as a daemon set, and the file for that daemon set is quite simple. You can see here it is where it is going to pull the information from, and I will actually do that in a minute and let you see what that looks like. You can see it has access to etc Kubernetes, the parent's etc path, so I can get the host name on which I'm running on. Is again a hack. The point is, this container or daemon set would have to have capabilities on the host to interrogate the host for the hardware capabilities, as well as access to the Kubernetes so that it can add labels to the node. So in reality, one of these would be going through the Kubernetes API as opposed to calling kubectl, which I'm doing in my little hack here. So if I look at what's in that file, you can see it's just a list of labels. It's real simple. And the detective really says, okay, if I'm on host K8s S1, then I'll set this label, 2 and 3, etc. You could also modify this so if you had a label with a minus after it, it would remove a label. It's just a way to kind of demonstrate how you could pull things from the web, use those definitions, because this could be a Python code or some script that you run locally, various ways to detect hardware. The point being the outcome of the hardware detection would be adding labels to the node in which you're running. So before I start the detectives, let me re-show the labels that we have, the standard labels and nothing there. Now what I'm going to do is I'm going to create the daemon set. And you have to use proper words, proper commands. There. And now that daemon set is created, and it's created in the ONAP space. So if I do git pods in the ONAP space, you can see, because it's a daemon set, it'll run one pod on each node. And so let me add wide here so you can see you have one on each node. Now there in the background, they've already downloaded the information from GIST. They've already interrogated the hardware, and the result of that hardware interrogation is show labels, label updates. So you can see for the first host, it's added that it has acceleration and it has persistence. For the second host, it has acceleration and it doesn't have persistence. And for the third host, it has neither acceleration nor persistence. Again, purely fake interrogation, but the idea would be that the results of interrogation would be labeling of the compute nodes with the hardware that they support so that Kubernetes can leverage that when it actually deploys VNFs. So now that we have those out there, let's actually deploy VNFs. So I have another little VNF container that I use as example. It really has nothing in it. It's pretty much asleep. Does a little bit more than asleep, like outputs a message, but that's about it. Really not important what that container is, because we're going to be watching more the location where Kubernetes chooses to put them. So I have a couple different files for deployments here, for pod deployments. I have a no persistence or no preference deployment, which basically, when you look at that, it says it's a very simple pod deployment, and it doesn't specify anything about where Kubernetes should be placing the pod. I have a must-have acceleration and persistence deployment, and you can see we're using a required during scheduling, ignored during execution. This is a node affinity setting. So what we'll see is Kubernetes over time will extend its capabilities with affinity. And if we have affinity needs that are not met by Kubernetes, my recommendation would be to work with Kubernetes to ensure that they are added, right? Or add them ourselves and contribute them back. So this one basically says, because this is a must-have acceleration and persistence, if this key has to be there, that label, and it has to be true, this label has to be there and has to be true. So Kubernetes will use that information when deploying. Then finally, I have a must not have either, and you can see it's very similar, except it says the value must be false. Or you could modify the persistence to say, look, it's not set. There's just, again, different ways you can modify the affinity capabilities. So we have that. The last one that I wanted to go over is actually a Jinja template. And this is because for preferences, preferred during scheduling, but ignored during execution, you can have something called a wait. And so I have a little script that will create a bunch of these with various waits, just so we can kind of see how Kubernetes chooses to schedule these. And so the only difference here is, again, I have what I have acceleration is always required. Persistence is preferred and weighted, and the script that I'll run will create a weights 1 through 5 and then 10, actually no, yeah, 10 through 100 at 5 point increments. So that's what that will do. So let's go off and create first. Create the no preference, create the must-have acceleration and persistence, and the must not have either. And we'll go create those VNFs. So Kubernetes now has scheduled those VNFs and deployed them. So we can do kube control, get pods into the namespace VNF. And we can see, oops, I do need to put that wide so we can see where they put them. And you can see must have both gets to K8s 1, K8s 1 because that's the only one that had both of those labels. Must not have them goes to 3 because, again, that was the only compute node that had those values specifically false. And then no preference 1 to 3 for no particular reason. That's where Kubernetes scheduled it. Now, I talked about a script. So demo create. You can see the script just goes for values 1, 2, 3, 4, runs the template and creates it for values 5 through 100, skipping 5s, creates the same thing. So let's run that script. And boom. And you can see it's creating the various VNFs with the various weighted preferences. Almost there, and now they're all started. Now I can get pods. A couple of them are still starting. There, now they're all started. So you can see with the preferences, it put this one on Kubernetes 2. Put this one on 1. Put most of them on 1 because it tried to hit the preferences, but occasionally it decided to schedule one on 2. So you can see with the preference capability, you can say, I do have a preference, and depending on how important that preference is based on weight, you can help direct the Kubernetes scheduler to the proper thing. You can also combine these with other affinity capabilities for that. So that kind of really is the end of the demo. The really point of this is Kubernetes has a capability with its labeling and with its affinity preferences that we could leverage for container-based VNFs for deployment on specific nodes matching the hardware. It'd be a combination of using the affinity characteristics of Kubernetes when we deploy a container-based VNF, as well as the ability to label the various compute nodes based on their hardware capabilities. That, again, could be done automatically through detection, kind of like I tried to demo today, or showed you kind of how that could be done with automatically using daemon sets, or it could be done as a manual process where someone goes in and says this hardware has this capability, or a more management process. So how the nodes get labeled can be done a couple of different ways, many ways. But the point is Kubernetes has the capability once those nodes are labeled to leverage that for VNF placement. And you can use that to match hardware accelerators, if you will, that a VNF-based container-based VNF requires to a physical compute node that has those capabilities. This project here is, I'll put it up on GitHub so people can download it and play with it themselves. It's based on another project that I've been working on, but the Kubernetes aspects should be able to run on any Kubernetes cluster you have, so you don't require to create it with VMs, but it is a self-contained demo if you want it. And again, I will put that up on GitHub. Have any questions? Happy to answer as best I can. Just give me some email. All right, thank you.